In this video, we're going to discuss the data science workflow. By the end of this video, you should know what the data science workflow is, why we use a data science workflow, and what are the main steps of the data science workflow. But first, it's important to take a moment and think about exactly what we're talking about here. What is a workflow? Again, a workflow is a standardized and repeatable process with steps that take a project from start to finish. So what is the data science workflow? It's a workflow applied to data collection, processing, analysis, and decision-making. Each of these steps is important to the data science workflow. And why is it that we have the data science workflow? Remember that it promotes the core principles of data science, which are reproducibility and transparency. And I can't emphasize this enough, you should remember that reproducibility is that every step of the workflow can be replicated precisely by anyone who has access to the data and the details of the workflow. Likewise, transparency makes clear what happens at every step and what the justification for every step is in the workflow for anyone who looks at it. Also importantly, the data science workflow allows multiple people or teams to work independently on the same project with a single goal. In this class, I'm going to present to you a stylized version of the data science workflow with a very general approach. The fact is that no single organization has a single archetypal workflow. Every organization is going to have its own business processes that will or may not follow the tenets of the data science workflow. So what does this general workflow look like? I've outlined it here in this flowchart. So as you can see, the data science workflow starts at the very left where you acquire data. After acquiring that data, you need to pre-process it, which means converting that data into a format that is usable by data processing software. After that, there's an exploration step where you might transform, summarize, visualize, or model your data. But all of that is with the goal of actually taking those data and then using them to communicate your results, make decisions, and then evaluate how well the data helped you make those decisions. And again, taking a look at this flowchart, you can see that this is an iterative process that never ends. Even after you make decisions, you want to evaluate and then reconsider every step of the data science workflow. So what are each of these steps in detail? The first step in the workflow is simply to acquire data. You can't perform data science, you can't do data analysis without actually having access to data. But even before you acquire data, you actually need to determine what kind of data you need for your analyses. And that's the specify step. In this step, you're going to actually write out or specify the type of data you need, but that also hinges on what type of data are feasible to collect. How much time, work, or money is required to obtain those data? How accurate are those data sources? And then how much of that data do you need to start making reliable decisions? You can't make decisions based on just one data point, but there comes a point after you've collected data where you feel like you can start making reliable decisions. These are all things that you're going to explore in the specify step. After you specify the data that you need, you then move on to the collect stage. This is where you obtain the data that you specify, but also importantly, you're going to archive and document the collected data so the original data is available in the future if anyone would like to examine it. And finally, you're going to be prepared to update the data in the future. If you're doing this as part of a business process, new data will constantly come in as the business operates, and you might want to use that to update your decisions. But also you may actually, through the evaluation steps down the road, decide that you would like to collect additional types of data. And as part of the collection stage, you need to be prepared to add those additional types of data in the future. The next step in the workflow is the pre-process step. This is where you prepare data for use in your data processing system. Data can come in a variety of forms, everything from electronic files all the way to receipts and shoeboxes. So it's important that you actually take those data and then make them usable by your data processing system. The first step in this is actually importing the data. This just means acquiring the data and loading it into your data analysis software in an electronic form. This can honestly be the most tedious part of the workflow. Again, data come in so many weird formats, and you'll have to take many steps to process the data just so it's actually able to be loaded and processed by your software. Also, this step requires careful documentation of the data that you collect. You identify the data sources, when you collected the data, because data sets might update over time. And also you need to make sure that you document whether or not there could be updates or revisions to the data. This is very important because as time goes on, someone may want to replicate your entire workflow, including the data collection and import step. And if the data has been updated in the meantime, they might get different results from you. The next component of the pre-processing stage is tidying your data. This is where you take the data that you've loaded into your data processing software and convert it into a format that's suitable for visualization and modeling. Importantly, we use the word tidy because tidy data sets are rectangular. This is very important for data processing software. In a tidy data set, every row is an observation and every column is a variable. Those are coded consistently across rows and columns, so you always know what type of data you're looking at when you look at a particular cell in your data. Getting your data to be tidy may also involve other types of wrangling. This includes dealing with missing data or cleaning up other inconsistencies in your data. So what do I mean by a tidy data set? This picture is an example of a rectangular data set. What you can see is there are a bunch of rows. Each row represents one employee. So each row is an employee at this fictitious business. So you see their name, their employee number, their email address, their phone number, and so on. Again, each row is representing one unit, in this case an employee. We're going to call these things observations. You'll also notice that each column in this table is consistent. The second column is the employee ID. It's always a number. It represents the identification number of that employee. The next column is the employee's first name. It is always some kind of textual information, which is always the employee's first name, and so on. This is the format you'll always see in rectangular data sets, where each column represents a unique type of information, and each row represents different observations of combinations of those types of information. The next major step in the data science workflow is the Explore stage. Your goal of this stage is to understand your data and the relationships between the many variables in your data. The first thing you're going to do here is transform or summarize your data. The fact is, your tidy data may not contain precisely the types of information that you're interested in. You can transform the data to create new variables, filter data, or make summaries to use in your analyses. As an example, from the table that I showed you just a minute ago, the data contain the hire date of an employee, but you might actually want to know the number of years they've been employed. The transform step would allow you to take the hire date of the employee and the current date and use that to compute a variable that's the number of years employed. The next step in the exploration stage is to visualize data. Before you can actually do any data analysis, you need to actually understand the data that you have. The types of questions that you might ask are, what type of variation do I have at each variable? Are there outliers that I might need to deal with or explain? And also, what do the relationships between the variables look like? In the visualization step, you'll create graphs or other graphical representations of your data to better understand your data and help you make good modeling choices. The next step in the exploration stage is the modeling or forecasting stage. An important goal of data scientists is to be able to describe relationships between variables and make predictions. Modeling uses your data to estimate the relationships between variables. Sometimes that relationship is all that we're interested in. But also in the modeling stage, you can use the data to start making predictions or forecasts about how some variables will change in response to how other variables change either now or in the future. The fact is, modeling can be an iterative process where forecasts are compared to actual values, and then the model is revised until you come to something that you feel is helping you make better decisions. The final major step in the data science workflow is the utilization step. This is where you actually take the data and analyses that you performed and use them to make better decisions. The first component of this step is the communication stage. I feel this is the most underappreciated role in data science. Again, data science is about making informed decisions. The decision makers, however, are often not the data scientists. Data scientists need to be skilled in communicating their results and recommendations clearly and to a non-technical audience. The next component of this process is the decide stage. The fact is, many data science projects end when the results are communicated to decision makers, they go on and make decisions, and you never hear anything else from them again. This isn't always the case. Some businesses make automated decisions based on input from data analyses and other sources. This is an iterative process, starting from the data collection stage all the way through modeling and decision making. In data science, it's very important to integrate all of this information and the steps of your workflow when evaluating the decision-making process. And that leads me to the last step of the utilization component, which is evaluation. Again, most decisions don't happen just once. After you've gone through this entire process through your workflow and made some decisions, you should examine your decision. Could you have made changes that would have helped you to do better? And importantly, you should consider all steps of the workflow when you're thinking about this, and where in the workflow could your process be improved. You might want to obtain more data, you may want to update the process of transforming and modeling your data, or you may want to update the process of how these all factor in and feed into new decisions. But again, having a well-defined data science workflow allows you to critically evaluate each step, update your processes, and feed that into making better decisions in the long run.